Science and technology. Makes you think about computers and space stations, doesn't it? But it should also make you think of much simpler things, like alarm clocks, hair dryers, pencil sharpeners. You see, science and technology are not just used by grown-ups with complicated jobs. You already have a lot of experience with both of these areas. Science and technology were part of our lives even before the cave dwellers built the first fire. They have grown together as human beings used what they learned about how our world works to make things that solved problems of living. And that is just what you will do in this class. Each activity in your textbook will give you a chance to take an everyday problem, learn as much about it as you can, come up with ideas on how to solve it, decide what tools and materials you will need to create a device that solves the problem, and evaluate how well your device works. Your teacher will guide you through each step of this problem-solving process to get to the solution, and you will indeed experience technology. The stars, the planets, the moon, and the light they generate and reflect have always fascinated us. Scientists and technologists down through the ages have experimented with the properties of light and created many different optical devices to solve many different kinds of problems. In this activity, you will have a chance to experiment with the properties of light as you build an optical device of your own. You could build such things as a telescope, a kaleidoscope, or a projector. A periscope is an optical device that is relatively simple to construct. A periscope allows people to see objects that are not in a straight line of sight. You've probably watched a television show or a movie in which the commander of a submerged submarine used a periscope to see what was going on above the waterline. As you build your own periscope, you will experience the scientific principle of light reflection, using mirrors positioned inside a hollow cylinder. To begin, you will need to learn as much as you can about light reflection and about periscopes. Your teacher will help you find information in your science textbook, project books, or in other reference books. Your library has many of these books. Next, sketch how you plan to use the principles of light reflection to put your periscope together. Then, make a list of the materials you will need and get them ready. Glass or plastic mirrors, plastic pipe or cardboard, glue, and a cutting tool. You will also need a ruler and a pencil, safety glasses, an X-Acto knife, and a file. If you use glass, be sure to cover all raw edges with tape so you won't cut yourself. Get your teacher's permission before you use any cutting tools and follow all safety guidelines. Now, follow your plan to put the periscope together, keeping notes that describe each step you take. Your notes will become part of a report you will prepare. Draw a development layout on the cardboard before you try to cut it to the desired size, and make sure you set the mirrors at each end at a 45-degree angle to the periscope length.
Draw that one across. You're okay. Now that's okay. That's fine. No problem. Now draw these other lines in. It goes across up here, and you can use these pieces for those too. Then we have to score the lines so that we can bend it. Doing very good. And we want to cut out the corners. You have that one cut out. Oh, you have both of them cut out already. And there's James with his periscope.
When you've finished, see if it works.
Hey, this thing really works. I can see you. I can see Tandra, Brad.
Is there something you could do to make it better? Finally, finish your report by describing how you used the scientific principle of light reflection to make your periscope. Light has existed since the beginning of the universe. But without the tools humans have devised to study that light, we wouldn't know much about it, and we wouldn't be able to use it, would we? So which came first, science or technology? What do you think? People, information, energy, tools and machines, materials, capital, time. Everything you need to produce your product, to get your job done. In this activity, you and your classmates will form a company of your own, and combining the 7 resources of technology will design and produce a prototype of a handheld game. It will be refined, if needed, and produced as your product. After your teacher has divided you into company teams, get ready to use your imagination and come up with a product idea. There are so many types of games you can create. One having to do with sports or movies, for instance. As long as it is handheld, no larger than 25 square inches in area, hand-operated with no electrical parts, and with a well-defined way of winning the game or completing the challenge.
We have some pegs here where we would drill some holes, and these would go in here. You'd want to make sure that the marble would hit, bounce around, and go down inside. We could put a spring on this thing, but if you put a spring on it, sometimes it gets in the way.
Your textbook has a list of materials and tools you might use to make your game. In this 3-level maze, for instance, you will need a marble, 3/8 by 3/4 inch strips of wood, 3/4 by 5 by 5 inch blocks, glue, and nails. When you and your teammates have agreed on what you'd like to make, what it will look like, and how the parts will be put together, you will want to think through all aspects of your design, how it will work, and ways you might be able to make it better. When everyone is satisfied with the design, go over safety procedures with your teacher. Build a prototype, a model of your game, and see if it works as you had planned. If not, this is the time to make changes.
And try to let the hammer just fall down and guide it, okay? There, you're doing just fine, doing fine, doing fine. All right, okay. A little bit more, Jesse, just one more.
Once your company team has designed a handheld game and built a prototype, marshal the 7 resources of technology to set up a production sequence, as though you were actually making the game to sell. For example, who will perform which functions? What information will they need to do their jobs well? What kind of energy will be needed to build the game? What tools, machines, and materials must be available? How will you pay for production of your game? How long will it take to produce it? When you are satisfied with your answers to these questions, have kept careful notes of the process, and have everything ready, make a trial run to see if the sequence works smoothly, and make any changes you need to make it more efficient. Your last step, then, would be to actually manufacture the game. People, information, energy, tools and machines, materials, capital, time. Product.
What you trying to do? Trying to get this marble out.
Are you a really fast runner? How would you get from one place to another if you had trouble even walking? Do you enjoy relaxing with a good book? How would you be able to read if you were visually impaired? Wheelchairs and eyeglasses are just 2 products of technology that have been designed to help solve problems like these. Most of us can think of something we have trouble doing, and science and technology have provided us with all sorts of devices to improve our ability to function in our everyday lives. In this activity, you will be the scientist and the technologist. You will identify a problem faced by someone with a physical handicap, and you will design a device that will help solve that problem. You might start by researching what devices for the handicap have already been invented. It might help to interview someone with a physical handicap to find out what is needed.
It's hard to walk. No.
What's your actual leg right
Yeah.
Pretending you have a particular handicap may also give you some ideas. To do this, you can put on heavy gloves and try to write, eat, and dress yourself to see what it's like to have arthritis. You can smear petroleum jelly on a pair of sunglasses and then wear them to find out how things look visually to an impaired person. Or you can put cotton balls or earplugs in your ears to experience what it's like to be hard of hearing. With this information and experience, brainstorm with your classmates and think of a safe, simple, inexpensive device you could construct that would make a handicapped person's life easier. One easy way to construct a model is with connecting blocks.
Something that would help a handicapped person. In this case, he has a wheelchair and he needs to get through here. I bet you there's some bumps that we could modify his wheelchair so we could start putting the blocks together and build.
You will all come together to experiment with the pieces of your rough design. Keep testing your model and making improvements until it works just as you want it to. Then, have someone else try it out to make sure it does what it's supposed to do. In designing and constructing your model, you have used the scientific method. You have identified a problem, you have researched the problem, you have produced a model for a technological device that will solve the problem, and you have evaluated its effectiveness. Science and technology, working together to improve our world for all of its citizens. Many early Americans settled by bodies of water simply because they could go no farther. How to get from here to there? It's usually not a problem for us now, is it? Advances in construction technology have crisscrossed our rivers and streams with bridges. Many different types of bridges allow us to get where we need to go. In this activity, you will build and test a model bridge of your own design. It can be a model of a deck bridge or a through bridge, designed with an arch or with trusses. Diagrams of the different types of bridge designs are provided in your textbook to give you some ideas. Notice how the different geometric shapes are used to make the bridges strong. You will work with your classmates in small teams to design and construct a bridge that will be as strong as possible using the least amount of materials. Some materials you might use to design and build your model are balsa strips, bridge layout sheets, glue, waxed paper, and cardboard. You will also need straight edges, cutting tools, a glue gun, scales, and lead weights to test for strength. After you have decided which type of bridge you would like to build, make sketches of your ideas on sheets that are the same size as the model you will construct. If you make 2 copies of your drawings, you will be able to use one of them as a pattern when you construct your model. Then prepare a bill of materials listing what you will need and get them ready to use. Now, following your drawings, build your model. Get your teacher's permission before you use any sharp tools and make sure you know how to use them. Be sure to wear your safety glasses. When you are finished, your teacher will help you use the scales to determine the weight of the bridge. You will then use lead weights to test the strength of the bridge. Look around you at the models other teams have built. Whose was the strongest? What is it about the design that makes it hold so much weight?
7, 8, 9.
Now ask yourself, if your bridge was actually built over a river, would you be willing to ride over it in a school bus? Horses, canoes, rafts, and covered wagons were all means of transportation used by our ancestors. Cars, ships, airplanes, and trains are what we use today. As technology has advanced, so have our systems of transportation. We carry more people, more places at faster speeds than our ancestors could even have imagined. And scientists and technologists are constantly experimenting with ways to make our transportation systems even better, faster, cleaner, and more energy efficient. Magnetic levitation systems, for instance, are being developed in Germany and Japan and are on the cutting edge of high-technology transportation. In this type of system, the energy of magnetic fields suspends and powers high-speed trains within a guideway. The natural laws of like and unlike magnetic poles are the underlying principles which levitate the vehicle and provide the power. Floating the train above the track almost eliminates friction and vibration, so the trains are faster and more durable. It's really a very simple idea, and you can build a model maglev yourself. In this activity, you will choose from tools and materials listed on page 311 of your textbook to build a model of a maglev vehicle and test it on a guideway. The width of the vehicle is determined by the distance between the rails. Your vehicle should be about 2.5 inches wide by 3 inches high and between 4 and 6 inches long. Carefully measure the dimensions of the guideway before you construct the vehicle base. Your vehicle must fit within the guideway and not touch it at any point. After you have made sure your base will fit, fasten magnets to the base with tape and test it to see if the magnetic poles are in the proper position. The base must levitate in the guideway and travel down it when the guideway is inclined. If it doesn't work, reposition the magnets. When you have proven that the base levitates and travels, fasten the magnets with glue or double-faced tape. Be sure to wear your safety glasses. Now, get your teacher's permission before you use any power tools and be very careful with sharp-edged instruments and materials. Design and construct a vehicle body to fit the base. You will want your vehicle to be as fast as possible, so as you plan how to make it, carefully consider the 5 components of vehicle design. They are propulsion, in this case gravity, control, the weight of your vehicle, guidance, the side rails of the guideway, suspension, the magnetic fields, and structure, the aerodynamics of the vehicle body design. When you played with magnets as a small child, you didn't realize you were gaining valuable experience that would help you do a job like this, did you? Perhaps this experience will help you design future systems only dreamed about in today's science fiction movies. With imagination, determination, and know-how, you can do it.
Craig wins it again. I think